All right, so we're now on lesson 9.5, and it's titled Using Distributed Property, but that's a little misleading. Technically, we're going to be undoing the distributed property, and this is a process known as factoring. Now, factoring is the process of expressing a polynomial. Remember, polynomial, a polynomial as the product of monomials. Should spell it right. Monomials or monomials. Monomials and polynomials. I'm right out of room here. Let's make that a little smaller. Nomials and polynomials. Okay, so factoring is the process of expressing a polynomial as the product of monomials and polynomials. Now remember, poly is a Greek term meaning many. Nomial is a Latin term meaning term. So you have a mathematical expression of more than one term. Mono means one. Okay, so that's just one term. And remember, product is the result that you get after multiplying two or more things together. So let's start off. Let's do a review really quick. So recall that the distributed property, I'll use two different colors. The distributed property is when you multiply in a mathematical expression that's in parentheses by a monomial or term or polynomial, it could be multiple terms, on the outside. So everything that's within this parentheses get multiplied by everything outside of parentheses. So in this case, my 2y plus 5 is going to get multiplied by 3y. So 2y is going to get multiplied by 3y. 5 is going to get multiplied by 3y. And another way we can write this is like this. 3y times 2y plus 3y times 5. And we'll get the same answer. So let's quickly prove that. 3y times 2y. So I'm going to have 3 times 2 is 6. Remember, y times y, we have two y's. So another way for us to write y times itself is y squared because we have two y's. This y represents a number. We don't know what that number is, so we just leave it as y. And we're going to have 2 of that number. Well, 2 of any number can be written as that number squared. So that's what we have here. Now we just move on to the 5. Let's erase that. All right, 3 times 5 is 15. This is a positive 5, so I'm going to have a positive answer because this 3 is positive, so 5 is positive. So a positive times a positive is a positive. So 3 times 5 would be positive 15. There's no y or there's no variable attached to this 5, so now I'm just going to tag on the y. And that's it. We can't combine like terms. That's as far as we can go. Because remember, we can only combine like terms when the variable is the same and the exponent is the same. Well, in this case, the variable is y. Yes, they're both the same, but this y is raised to the second power. Right here is raised to the second power. This y is just raised to the first power. So because the exponents are not the same, we can't combine like terms. So we have to leave it like that. All right, let's do the other side of the equation. See if this is equal. 3 times 2 is 6. As we said before, y times y is just going to be y squared. All right. And just like we said before, 3 times 2y, we already have that here. But we're also going to have 3 times 5. everything in parentheses. We just broke it up on the right side. So we have 3 times 5 is 15. And then we have y times 5. Well, that's just y. Because remember, this 3 is attached to the y. So we're going to have 3y times 5. There's no other variable here, so we get the same answer. And look, they're equal. Okay? We just rewrote it, what we have on the right side, we just rewrote it as a different way. Now, when we factor is undoing this distributive property to where we rewrite our polynomial. In this case, our polynomial is 2y plus 5y. We undo it by factoring. In other words, we actually divide out a common term between these two. Okay, so this is where knowing multiplication comes in handy. Now, if you look here, we're going to review something what's called our GCF. And GCF stands for our greatest common factor. And let's do this. We'll make these different colors so it stands out. So in other words, out of these numbers, okay, what is the greatest or what is the largest number that both 6 and 15 have in common that we can divide both of these numbers by? So when we say divide both of these numbers by, the number has to be the same. That's what makes it common. So the largest number that we can divide both 6 and 15 by, to where they both have it in common, is 3. So if I divide my 3 by 6, or excuse me, if I divide my 6 by 3 and my 15 by 3, well, guess what? I can factor out, I would have left over 2y, and I would have left over a 5y. Okay. So because we divided both these terms by 3, technically I factored out a 3. Okay. Now, but guess what? We can also factor something else out. Both of these monomials, or both of these terms, also have a y. Now, here's the tricky part. You have to make sure you pay attention. This 2y has one more y because we have 2 of them, right? Did you look at this exponent? We have one more y than this one. So when I factor out a y, right, I divide both of these terms by y. That's what we mean to factor it out. Technically, I would pull out my y. The y comes out. Now remember, this has 2 y's. So I'm going to have 1 y left over. That's all we're left for 2y. I only have 1 y here. So that 1 y comes out. So now I just have 5 left over. Now if you notice something, look what we started with. We have the same thing. We just undone what we did here. Remember, we multiplied the 3y by everything inside here. Now, we just undone it. We undone what we just did. We did distributive property, but now we went in reverse. Now we factored out the 3y. So instead of multiplying everything by 3, we divided it by 3. Everything inside here by 3. So factoring is pretty much the reverse of distributive property. Okay, so let's move on to some more examples. Let's do another problem. Okay. So the next problem we're going to do, and let's start with a different color. The next problem we're going to do is going to be 12a squared plus 16a. Excuse me, taking a sip of my tea. So we have 12a squared plus 16a. Now remember, we want to factor out the greatest common factor. In other words, we want to find what number that's the largest factor that we can divide both 12 and 16 by. Okay? Now, just for review, if some of us don't know our multiplication that well, we're going to do that. So, our factors of 12. Okay? Factors of 12. Well, we know 1 times 12 will give us 12. Okay? And let's do a different color so it stands out. We know 1 and 12 will give us 12. Okay. What about 2 and 6? Okay. And what about, let's move this over so we have a little more room. What about 3 and 4? Okay. So I think that's as much as we can get because 1 and 12 is the highest. 12 is the largest number we can do. And then as we go further on, 6 and 4. So we have, these are largest numbers, largest factors of 12. Okay, now let's do 16. Let's do 16. So we know our multiplication. Okay. Obviously, we know that 1 times 16 will give us 16. What about 2 and 8? 2 and 8 will give us 16. Okay, but if you notice, only 2 matches up. Only one matches up. Or excuse me, only 1 matches up. Only 2 matches up between these two. So we got to keep going. We also know that 4 times 4 will give us 16. Now, if you notice, look, 4 also matches up. Well, out of the terms that match up or the numbers that match up that we have in common, remember, they're common because they're the same between 12 and 16. So out of the numbers that we have in common, 4 is the largest. So because it's the largest, it's our greatest factor that we have in common. That's our GCF, our greatest common factor. So 4 is going to be our greatest common factor. So now I'm going to factor out of 4 from these terms. Okay, let's do that. So if I factor out of 4, technically I'm dividing this 12 by 4, and I'm dividing 16 by 4. So I'm automatically going to put my 4 out here. Okay. Now also, if you notice here, and I'm kind of jumping ahead, but I want to go ahead and make it a habit to where we can do it in all one fell swoop, where we can factor out a variable and our greatest common factor, which is a number. Because we have more than one a here, and there's an a here and there's an a here, because the terms or the variable is the same for both of our numbers, or our coefficient. Remember, the coefficient is a number that's in front of a variable, or a number that's been multiplied by a variable. Because we have an a attached to both of our coefficients, our 12 and our 16, I can pull out an a as well. Okay? Now remember, I have 2 a's here. I pulled out 1 a, so I'm going to have 1 a less, or 1 less a. All right, so after we've divided our numbers, we'll get to the a. 12 divided by 4 is going to give me 3. I'll do this in a different color. 12 divided by 4 is going to give me 3, so I have that left over. Okay. 16 divided by 4 gives me 4. Now remember, we also factor out an a. We took 1 a from here, so I'm left with 1 a that's left over. Remember, this one only has 1 a, so that means we don't have any a's left over. So if we factor that, now we're left with 4a times 3a plus 4. And we're done. That's it. We just factored it. Now, to make sure that we're right, let's just distribute everything back in to make sure that we're right. Okay. 4 times 3 is 12. And remember, a times a is going to be a squared. All right, now we go to the next term. 4 times 4 is 16. And remember, this is a positive 4. This is a positive 4. So now I'm going to have a positive 16. And remember, a times 4, well, that's just going to give me my a, right? I attach that on. Okay, so we can do this all in one fell swoop. If you want to say 4a times 4, well, that would be 16a. Because remember, there's no variable here. It's empty. So we just tag on the a. And look, we got the same thing that we started with. So we know that we did it right. We'll do one more. One more. Now we're going to do a trinomial. Remember, tri is a Latin prefix for 3. So we'll do a trinomial. Okay? So my trinomial is going to be 20x squared times y squared minus 45x squared times y minus 35x squared. Okay. Now, I'll give you a hint. Anytime you see numbers ending in 0 or 5, you know that 5 is a factor. Because if you count by 5s, you know this pattern. 5, 10. There's a 5, and then the next term after we add a 5 is a 0. 15, 5, 20, 0. So anytime you see a 0 or 5 at the end of a number, you know that 5 is a factor. Okay? So we already know we can obviously factor out a 5 from each of these terms. But we want to check and see if 5 is the greatest common factor of those terms. So now, we already know 5 is 1, but let's see if it's the greatest common factor. Well, I know that I can divide 20 by 10 as well. Not just 5, but I can also divide it by 5. I can also divide it by 10. I can also divide it by 20, and I have 1 left over. Okay? However, 20 is not a factor of 45, and 20 is not a factor of 35. So that's too big. 10 is not a factor of 45. 10 is not a factor of 35. Okay? So I think our greatest common factor in this case will be 5. Now remember, when we factor, we're technically dividing each term by the largest number that we can divide each number by. It has to be the same. It has to be the same number that's the largest that we can divide each term by. Okay? That's where we get greatest common factor from. So in this case, the largest number I can divide 20, 45, and 35 by, that's the same as 5. So remember, I'm going to factor that 5 out. So I pull that 5 out. Now, we did our greatest common factor. Let's go to our variables. If you notice, each one of these terms have an x squared. So that means I can factor out, or I can divide out every single one of these terms by x squared. Right? I can pull x squared out of there. Okay? And then I'm done factoring. Now, I see that there's a y here, or y squared, or y here, but there's no y here. So technically, I can't pull a y out of all these terms. So we'll just stop there. We'll have to leave the y's alone because we can't factor y out of every single term. And I don't want to jump ahead into grouping. So we'll just stop there. So now that we factor out 5, now we have to go and see what we have left over when we divide each of these terms by 5. Okay, 20 divided by 5 will give me 4, right? And remember, we factor out the x squared, so the only thing we're going to have left over is y squared. All right, now we're done. We're going to move on to the next term. Remember, we have a positive 5, and we're dividing a negative 45 by a positive 5. Well, negative divided by a positive is negative. So we already know we're going to have a negative answer left over, a negative quotient, right? All right, negative 45 divided by positive 5 gives me 9. Okay? Remember, we already factored out an x squared, and we factored out is right here. So that x squared is gone. We used all the x's up, right? That's why it's to the second power. So I'm just going to be left with y. Okay? Now we're going to go to our 35. Well, remember, we have a positive 5, and we're dividing our negative 35 by a positive 5. A negative divided by positive is negative. So we already know we can automatically put a negative here. All right? Negative 35 divided by positive 5 gives me a negative 7. We already have a negative here. We just put our 7. Remember, we divided out the x squared. So there's nothing left to bring down. So we have no more variables to bring down. And that's it. Now, if you notice, we have a quadratic. Remember, anytime we have a quadratic, our leading term is some variable squared, right? And then it just goes down the line. Okay? This to the first power. Even though there's no 1 there, it's to the first power because anything raised to the first power is going to be itself. That's why they don't put the 1 there. And if you notice here, our 7 doesn't have a variable. It's what we call a quadratic. When it's in the form where we have our leading or our polynomials to the second degree, remember? Whatever your highest exponent is, that determines what degree the polynomial is. So this is a quadratic, okay? And that's it. We just factored this. All right, so now I want you to go on Alex and you finish practicing. Now, before we do that, though, before you go on Alex, I have one other thing I want you guys to go over. That's in the next video. So go to the next link in Canvas and click on that video. Factoring by grouping.